Wet bulb temperature by Monica Soul.
And Pablo Gomez.
What is wet bulb temperature? A wet bulb measures the temperature read by a thermometer covered in a wet cloth. Evaporation cools the thermometer when the water vapor leaves the fabric. This is similar to how sweating causes the body to cool down. How do you calculate the wet bulb temperature? A. Read it as is. B. Using a thermometer with the bulb wrapped around a wet cloth. C. Add heat to the bulb. Or D. Using the quadratic formula. If you guessed B, you guessed correct. Using a thermometer with the bulb wrapped around a wet cloth.
So the dry bulb temperature, usually referred to as air temperature, is the air property that is most commonly used. Usually, when people talk about the temperature of the air, they mean the temperature of a dry bulb. The ambient air temperature is essentially what the dry bulb temperature refers to. What is the difference between dry bulb and wet bulb temperature called? A. Dry bulb depression. B. Wet bulb depression. C. Wet bulb difference. Or D. Dual bulb temperature. If you guessed B. Wet bulb depression, then you are correct. Here's a short video on explaining wet bulb and dry bulb temperatures.
Obvious to me when I learned about wet bulb temperatures. Let's say I tell you the temperature today is 10 degrees Celsius. You can do something with that information. You might think, that sounds a bit chilly. Maybe I need a jersey before I go outside. If, however, I tell you that the wet bulb temperature is 10 degrees Celsius, there's not much you can do with that information by itself. It could mean that the day is going to be chilly and you need that jersey from earlier, but it could also mean that today is going to be a scorcher, you're going to need sunscreen, and you're going to have to drink plenty of water. The word bulb in both wet bulb and dry bulb temperature refers to the bulb on a mercury thermometer. That's the little bit in the bottom. That's the reservoir that contains the mercury, which expands and contracts as it heats up or cools down to indicate temperature. Dry bulb temperature is simply temperature the way you've always understood it. Wet bulb temperature is measured by wrapping the bulb in a water-soaked cloth, also known as a wick, and passing a large amount of air through that, or spinning it around a lot so that you get a different temperature. Now, wet bulb temperatures are usually lower than dry bulb temperatures, and that's easy enough to understand. You already have a feeling for this through your experience of going for a shower. When you step into a shower, it's not like you're necessarily cold before you step in. You have your shower, then you step out, and all of a sudden it's only after you've stepped out that you feel cold. And that's not because the air in your bathroom is now lower than when you started, nor is it because the water coming out the shower is now cold. It was warm a minute ago when it came out the shower head. The reason you're feeling cold is because the water that's on your skin is an energy thief. As it evaporates, it goes into the air. It requires energy to do that. That energy is known as the heat of vaporization. The water is an energy thief that takes its energy to evaporate from your skin, and that feeling on that leaves your skin feeling cold. It's the same thing when measuring wet bulb temperature. This is quick and easy to demonstrate. Here I start with the air temperature in my kitchen at 18 degrees Celsius. I've let a glass of water stand overnight so that it comes to the same temperature as the air in the kitchen. You can see that when I place the thermocouple into the water, there's basically no change in the temperature. But look at what happens when I take the thermocouple out of the water and expose it to air. Just like you feel cold stepping out of the shower, the thermocouple feels colder because the water takes energy away from the thermocouple as it evaporates. This isn't a completely accurate measurement of the wet bulb temperature because to do that, I'd need a constant supply of water in the form of a wick to my thermocouple, and I'd also need to be shaking it around to get a good airflow across it. So wet bulb temperatures are always lower than dry bulb temperatures. Don't memorize those words, you already understand this. You're only cold when you're wet coming out of the shower, not when you're dry going into it. Even though we don't really use mercury thermometers nowadays because everything's digital, we still talk about wet and dry bulb temperatures, despite the absence of an actual bulb. So where are we going with this? Let's consider what happens in two scenarios. Let's have two thermometers, both of them reading 20 degrees dry bulb temperature. Remember, dry bulb, regular temperature. But imagine one of these is measuring the temperature on a day that is very dry, so there isn't a lot of moisture in the air, while the other is measuring 20 degrees on a very humid day. You know those sweaty, clammy days that you get sometimes, depending on where you live. Let's wrap both thermometer bulbs with this wet cloth, the wick. For the dry day, the rate of evaporation of water will be very high because there is plenty of space in the air for the water to escape into. The more water escapes, the more energy it steals from the thermometer. So my thermometer reading is going to be very low. For the really humid day, there isn't much space in the air for the water to evaporate. It's like trying to hang up laundry on a humid day. It'll take forever for your clothes to dry. If there's no space for the water to evaporate, the water stays in the liquid phase and it is not able to steal energy as it vaporizes. Because it isn't doing that, the thermometer reading is not going to be as low. So this is the first part of your answer. It could be that someone is talking about wet bulb temperature not because they are interested in the wet bulb temperature reading itself. They're actually interested in the difference between the wet and the dry bulb temperatures. The bigger the difference, the drier the air. If there's zero difference, that would mean I have air with 100% relative humidity. The air is saturated with water and there's no space for water to evaporate and hence drop the wet bulb temperature. So a high wet bulb, meaning one that is close to the dry bulb, simply means I have very humid air.
What affects wet bulb temperature? A. When it evaporates. B. Making noise around the bulb. C. When the bulb is dry. Or D. If the humidity of the surrounding air is high. The correct answer is D. If the humidity in the surrounding air is high.
So true or false? Is water an energy thief? Does it steal energy in order to evaporate? If your answer was true, then you are correct. Water does need to use energy in order for it to evaporate, and that is why you feel cold when getting out of a pool or a shower.
In conclusion, the wet bulb temperature is the temperature of adiabatic saturation. This is the temperature indicated by a moistened thermometer bulb exposed to the airflow. Wet bulb temperature can be measured by using a thermometer with the bulb wrapped in a wet muslin. Why is the wet bulb temperature always lower? A. When evaporation takes place, heat escapes with the water and starts cooling down the bulb. B. Because the speed of light. C. Because Professor Jason said so. Or D. Because it snows. You guessed it, the correct answer was A. When evaporation takes place, heat escapes with the water and starts cooling down the bulb.
So dry bulb temperature, DBT, is measured using a mercury thermometer. The mercury thermometer has a glass tip infused with mercury, and that tip is used plain like that in order to measure the temperature of the air. Another fact about DBT is that wet bulb temperature, WBT, can never exceed the dry bulb temperature that is relevant to it. Typically, when someone talks about the temperature outside, they refer to the DBT, dry bulb temperature. The bigger the difference between the DBT and the WBT, the drier that day is, because when it is humid out, water on the thermometer has a harder time escaping. Similarly, doing that for your own body. Can the wet bulb temperature exceed the relative dry bulb temperature? A, yes. B, maybe. C, no. Or D, I don't know. I hope you didn't guess D. So the right answer is C. The answer is no, because it's not possible for the wet bulb to ever be as accurate at measuring the true temperature as the dry bulb.
Thank you guys so much for watching.
Thank you for watching.